Good day, everyone. How are you all doing in 2024? I'm really honored to make a presentation about CTR technology for you. From now on, let's start it. Here is a summary of the main topics as follow. First, I will tell you about CTRAM R&D development capability. Second, I will share CTRAM product features and know-how. And I will share results to compare with competitor products. Last, I will share you about some information which we heard several times in our seminar, like self-wrongness and issues caused by incorrect assembly of the stabilized link. First is CTRAM R&D development capability. Starting with research activities at CTR R&D Center since 1990, we have achieved some important technological development. And since the establishment of the R&D Center for the Aftermarket in 2015, we have been training specialized professionals for the aftermarket. CTR R&D possesses research expertise based on OEM know-how and experience. Even half of the engineers have OEM careers, and we retain advanced research tools for design, analysis, and 3D scanner. We also retain over 50 equipment in our test laboratory like performance, strength, and so on. Even we possess technology development materials, especially we have been using CTR on grease and we have analyzed various materials like material without heat treatment and so on. Now let's take a look at how CTR designed the product. Unlike our competitor, we don't just copy genuine parts. From step 1 specification review to step 5 design freeze, we follow CTR unique design procedure as OEM. First, we review static and fatigue road cases, test specifications, operating angles, target mass, and package interfaces. Following this, we carefully select ball bearing materials and size based on allowable surface pressure calculation. Then we set fixed materials and dimensions for all components. To ensure confidence in our choices, we conduct FE simulation analysis. If the result meet our standards, we finalize the design. If any aspect falls short, we revisit and make necessary adjustments. This page shows our new technology. CTR have the technology to develop hybrid stabilized link and optimized model for the electric vehicle era. Hybrid stabilized link is made of polymer allowing corrosion regardless of surface damage. CTR's hybrid stabilized link weighs up to 38% less than steel-type product, improving aluminum alloy and reinforced fuel efficiency with reduced carbon emissions. Based on the OEM standard, we can manufacture the new items like hybrid stabilized link. As you can see this slide, generally our products insist of those parts. When it comes to our material standard of those parts, we apply the same materials to each part as the OEM business department. From the top, the boot material is CR with HWG. In this slide, this shows the result of the boot durability test between CTR and A and B companies, which are global top aftermarket brands. At the top right the table, it shows the pictures right after we assembled test jig. A and B are already twisted and which stands for heat, water, and grease resistance. The second material is S45C with quenching and tempering heat treatment and additional surface treatment. From this slide, I will share you about CTR product features and know-how. CTR applies the latest technology for our product. In case of the ball seat, we use ceiling type ball seat like polymer one. Some of you think that the ceiling type of ball seat is weaker than a grease nipple type one. And that is better solution than a ceiling type one, which make you prefer grease nipple type. As you can see this slide, grease nipple type ball seat was also used well, but in the past. Auto parts have developed a lot over time, and so has the structure of the joint. With the development of the new technologies, the performance and durability of the product have increased significantly. That's why OEM companies have developed new type bolts that use new material like polymer, used new design, which is sealing type 1. These days, almost of the oil companies use the sealing type bullshit for not only the passenger vehicles, but also heavy-duty vehicles like pickup size truck or van and something like that. It means the sealing type bullshit is very useful and up-to-date version. Don't be worried about the strength of the sealing type one. And CTR applies the optimum design of the boot for our product. When the car is driven on an uneven road or goes over a bump or is in similar situation, joints experience oscillations and rotation like this video. At the right side of the image, it's an initial state product right after we assembled it. As shown in the zoom-in part, there is very little clearance between the bolster and the bursted, as if there is no clearance. So initial stated joint keeps proper torque for oscillations and rotation motion. But if there is water inflow caused by boot damage, bolted corrosion will be awkward. Strength of the bolted will be weakened, and torque will be dropped with reduced lubrication. Presupposed lubrication of the joints. If it mixed with water, it will lose its functionality. Just as with water inflow, dust like soil or debris inflow will also cause wear on the bolted. And owing to the grease contamination, lubrication will be compromised. If we don't consider this movement, boot can be negatively affected, which can lead to bolted premature wear, vibration, and noise. In the worst case, bolted can be pulled out. That's why it's necessary to apply the optimum design of boot. So when CTR develops new items, CTR checked excessive volt, waste, gap between the boot and related parts, and self-contact in advance through the FE analysis. And through the various sample tests like boot durability test, high pressure leakage test, seal twist test, and so on, CTR checks boot durability and sealability. Then, don't you wonder how much CTR is different with the competitors? For it excessively, just as it is we tested. A and B were toned in the middle of the test. Water and mud got inside the joints. Unlike competitors, CTR had no tear, no puncture, no slit. And next shows the corrosion resistance test result of the ball joint between CTR and Asian aftermarket brands. One of CTR products' strong point is CTR adhere to corrosion resistance standards as much as oil company standards. As you can see, A and B have no surface treatment. So after 48 hours, those awkward red rust. Whereas CTR has no red rust after 240 hours. This is the material inspection result of the CTR and competitor, which is one of the Asian aftermarket brand. We analyzed from bolted to bolted grease. Among those, there are two specific things, bolted and socket material with heat treatment and boot material. CTR applies to special heat treatment to enhance mechanical properties for each part. And we also use better quality rubbers for boot, including durability and resistance to various environmental and chemical factors. It shows the detailed result of the hardness measurement at the center and near the surface of the bolted. In case of the hardness, we checked whether products meet general hardness specification, which is common automaker requirement or not. Because if the hardness is higher than the specification, there is a risk of the crack when the screw is tightened. Unlike if it is lower than the specification, it will be easy bending. Anyway, hardness measurements were taken at key location, and it was confirmed to be at 48% of the level compared to CTR. Furthermore, the hardness of the A does not meet the general specification. Next is socket hardness. This is the same with bolstered one. A does not meet the general specification too. And we checked exterior and dimension of the CTR and competitor. As you can see through the table, CTR and competitor is almost similar, but both the table angle is different. CTR is 1/8, which is same with genuine product, whereas A is 1/6. That is very severe defect. It might be possible to assemble with related parts like knuckle, but it might occur the bolstered crack in the middle of driving. From now on, I will share some information that customer asked us several times in previous our seminar. This is convenient kit self-lock nut. In the field, we usually use three types of nut: castle nut, flange lock nut, and nylon nut. Among those, we call the flange lock nut and nylon nuts self-lock nut. In case of the castle nut, we have to use nut with split pin for locking, so it's quite complicated. Whereas flange lock nuts and nylon nuts are easy to use and have good durability. These days, many car brands use self-lock nuts in their model like Ford F-150, a Volkswagen Polo, and so on. Lost contact is an issue caused by incorrect assembly of the stabilizer link. You can see through this slide, this shows the proper stated assembly of the stabilizer link. If you assemble the stabilizer link with related parts like stabilizer bar, yoke, control arm, etc. well, bolted is at a 90-degree angle to the road axle. But some engineers make a mistake to assemble stabilizer link in the wrong direction, which means that they assembled left-hand product to right-hand directions and right-hand product to left-hand direction. If we assembled in the opposite direction, as shown in the picture, it would cause camped out. As shown on the right side, upon analyzing the defective product, we observed deformations on the inner left and right parts. On this page, let's look at the normal and wrong stated assembly related to the stabilizer bar. As shown on the top of this slide, the assembly position of the stabilizer bar and the counterpart matches, and this product is assembled at a 90-degree angle like right side picture. Whereas we are looking at left side situation where the assembly positions of the stabilizer bar and control arm don't align vertically. As you can see in the picture, the assembly positions don't align correctly. And there is a right side situation where the assembly of the stabilizer bar is incorrectly done either to the left or right. In this case, there are a gap between the control arm and stabilizer link, and you force them together. Both of cases could also be caused by bolts that came out. This occurs when the product operates outside the normal range. There are general reasons why bolted up stabilizer links are came out. So if you check before and after you assemble product, the frequency of the came out is lower than before. I'm really pleasure presenting CTR technology. I hope this talk seminar has convinced you to choose CTR for your future automotive needs. Thank you very much.